Hey there, this is René Molenaar for GNS3 Vault, and in this video I'm going to show you how to solve the recursive routing failure lab. Okay, so what do we have? Three routers, Japan, China and Australia, and there are two things that I'm going to do. First of all, I'm going to configure RIP version 2 on all of those routers so that we have full connectivity, and then I'm going to configure a GRE tunnel between Japan and Australia, and I'll show you what happens then. Okay, so what we're going to do is use the network 0000 command, because it will advertise all of my interfaces and it will send RIP updates on all of the interfaces. So let's get started here. So router Japan, router RIP. I'm gonna do no auto summary, version 2, and then I'll advertise all of the networks. And let's just copy and paste this to the other two routers. So that's number 2 and number 3, there we go. So the reason that I need to configure RIP before we can do the GRE tunnel is because I'm going to configure the GRE between Japan and Australia, and that means that router Japan needs to know how to reach the 23.3 address, and router Australia needs to know how to reach the 12.1 address. So let's do a show IP route here on Japan. You can see that it knows how to reach the 23 network, and I should be able to ping it. There we go. And we can do a show IP route on Australia, and you can see that it knows how to reach the 12 network because of RIP. Okay, so far so good. Next step, let's create that tunnel interface between Japan and Australia. So on router Japan I can do interface tunnel 0, and then you need to specify a tunnel source, which will be 12.1, and the tunnel destination will be 23.3. And of course I need to do the same thing on router Australia here. So tunnel 0, and then tunnel source 23.3, and tunnel destination will be 12.1. There we go. Okay, so you can see the tunnel is now up. The tunnel interface is working. Show IP interface brief. You can see that we have a tunnel interface and that it's up and up. So that's all good. The next step is to configure network 192.168.13.0/24 on the tunnel interface. So we're going to set an IP on the tunnel interface. So on router Japan I'm going to use 13.1, and on Australia I'm going to configure 13.3. There we go. So let's try to ping the other side, and you can see that it's working. Okay, at this moment I got a tunnel interface, I got the IP addresses configured on the tunnel interface, but now we will see some funky stuff going on. So let me explain you what will happen here. So on all of those three routers I configured RIP, and I also typed in the network 0000 command. So that means that it will advertise all of the networks that I have configured on each router, and it also means that it will send RIP updates on all of the interfaces that I have. So what we will see is, because between router Japan and Australia I created this GRE tunnel, and I set an IP address on both routers. So those two routers will also send RIP updates on the GRE tunnel interface. Now let me show you what the problem will be. And you can already see it here on router Australia. So it says tunnel 0 temporarily disabled due to recursive routing, and you can see that it's now down. So why is this happening? Let me do a show IP route here. And this will take a little while, but I can check route to Japan maybe. Do show IP route. So let's wait a little until the tunnel interface is back up. You can see it's happening, it's right up. And if I do a show IP route now on router Australia, you can see two entries over here for the 12 network. So router Australia has just learned that it can reach the 12 network by going through the fast Ethernet interface or by going through the tunnel interface. Now that's kind of funny, because if we look at the topology picture, so I'm looking at the routing table of Australia, and it just has learned about the 12 network, which is the link between Japan and China, and it thinks it can reach this network by going through the fast Ethernet link or by going through the GRE tunnel. But the problem here is that the 12.1 IP address on router Japan, that's our destination for the tunnel interface. So router Australia needs to be able to reach the 12.1 IP address to build the tunnel, and as soon as it has built the tunnel, then it thinks it can also reach the 12 network by going through the tunnel interface. So what we have here is kind of like a chicken or egg problem. So we got a tunnel, the tunnel is working. As soon as the tunnel is up, router Australia thinks it has learned a good path to reach the 12 network by going through the tunnel interface, and then the tunnel interface will collapse because it's not going to use the fast Ethernet link anymore. And in my example over here, you can see two entries. So there's one entry for the fast Ethernet link, and there's an entry for the tunnel link. So in this case it will do load balancing. So it will use the fast Ethernet link, and it will also use the tunnel interface that we have. So that's recursive routing. And the problem here is that I'm using RIP on the tunnel interface, and I'm advertising stuff through the tunnel interface. So what I need to do in order to fix this problem, there are two options that I have. Option one is that I can increase the hop count for whatever I advertise through the tunnel interface. So let's say, if I look at this routing table again, let's say for router Australia, in order to reach this 12 network, the hop count is 1 by going through the fast Ethernet link. And if the hop count would be 5 or something else, so even 2 would be good enough, by going through the tunnel interface, then it will never use the tunnel interface, and it will only use the fast Ethernet link. So I could fix it by increasing the hop count for the tunnel interface, and of course you need to do this on router Japan as well. That's one way of fixing it. The other method of fixing it is by making sure that you do not advertise anything through the tunnel interface. So router Japan and router Australia shouldn't be sending any RIP updates through the GRE tunnel interface. And that's another method of fixing this. So let me just show you how to do this. And let's start with the easy method first. So go to router RIP, and here you can say passive interface tunnel 0. And I need to do the same thing on router Australia. Passive interface tunnel 0. This will fix my problem, because now we are no longer sending RIP updates through the GRE tunnel, and router Japan or router Australia are not going to learn anything through the tunnel interface. And that will fix my problem. So over here we can see that the tunnel is up. Over here we can see that it's down at the moment. And let's wait a little bit, because you will see the tunnel should come back up, and it's not going to go down again. So right now it's up. We can do a show IP route here. And you can see that router Australia is only using this entry over here. In order to reach the 12 network, it will use the fast Ethernet link. And we don't see the tunnel interface anymore because I'm not advertising RIP updates on the tunnel anymore. So this is one way of fixing it, and it's the easiest method. But let me show you the other method as well. So let's get rid of the passive interface stuff. And what I'm going to do is use the offset list command. And let me show you how it works. So the offset list command, you can use it to increase the hop count. And the first choice that we have to make is for what networks am I going to apply this. And I'm going to do 0, so it will apply to all networks. 0, you can choose inbound or outbound, and I can do outbound here. Offset, that's the hop count, so let me just set it at a hop count of 10 or something. And then you need to choose the interface. So I'm going to choose the tunnel interface. And I'm going to do this on both routers, so Japan and Australia. Copy and paste it, here we go. And let me enable a debug here so you can see what is going on. Debug IP RIP, here we go. So we're receiving an update on the fast Ethernet link, and you can see this network, 1 hop, 2 hop, that's all good. Let's see what else that we can find. So the tunnel interface is up again. There we go. So this is what I'm looking for. RIP. Let's turn off the debug. So it says RIP received update from 13.1, so that's the tunnel interface. This network with a hop count of 11 and this network with a hop count of 12. And on the fast Ethernet link we are receiving the 12 network with just 1 hop. So if we do show IP route, you can see that we are only using the fast Ethernet link because it's only 1 hop compared to 11 hops for this network. And you can do show IP route on router Japan as well, and you will only find 1 entry over here, which is the fast Ethernet link. Okay, so that's basically it. So this is how you can deal with recursive routing issues. So there are a couple of methods of solving this. One of them is by increasing the metric for the tunnel interface. That's one way of fixing it. And the other method is that you can use the passive interface and apply it to the tunnel interface. Keep in mind, I used RIP for my example, but you also need to be aware of recursive routing issues when you are doing OSPF or EIGRP. Anyway, I hope you enjoyed this video. I hope it was helpful to you. Thanks for watching, and till next time.